Hi, everyone. It's a great honor to be here speaking to this audience, super energetic audience. I want to thank Mark and Joy for the privilege first. So I'm going to start this talk by asking a question first. What do you guys think the Australian police force and the Japanese fishing company have in common? Yeah, it's a trick question. I'm that kind of professor. So to answer that question, I'm going to take you back to 2014. So in 2014, Jason Mars, he's in the audience, my colleague and partner in life, and I open sourced the software called Siri. As you probably can guess, it means Siri for us. So it's a software that allows everyone to build their own virtual assistant or voice-enabled conversational AI. So we put this on GitHub. We got tens of thousands of downloads in the first month. I started to get phone calls from companies like Wells Fargo, GE, and Ford and say, can you help us build this conversational AI or virtual assistant? And among those phone calls, here are two interesting conversations I had. One is from police officers in Australia, and the other is from a fisherman from a Japanese fishing company. So it turns out that they both want to talk to their computers. So the police officers want to have a conversational AI in their car, so while they're driving down the road chasing bad guys, they could ask questions like, can you please run this license number 123456 and give me the criminal records of the driver? Right? The fishermen want to be able to present the fish in front of the computer and ask questions such as, what type of fish is it? Can I get to keep it? Tell me more about the regulations of fishing for this kind of fish, right? But if you really think about it, humans have been romanticizing, fantasizing about talking to computers for decades. So in 1960s, in Star Trek, you want to be able to talk to your computer, ask questions about the planet. 1970s, have a small chat with a murderous computer. In post-2010, you want to talk to your virtual assistant companion, build an intimate relationship, maybe went a little bit beyond just friendship, right? Spoiler alert. Now back to the reality, right? The disappointing reality. So this is what Google thinks, what you guys think about Alexa, Google Assist, and Siri. The sentiment is pretty negative, right? If you see this autocomplete from Google, it's Alexa not working, Google Assistant is bad, Siri is actually bad and not working, right? Is this the best we can do? It's incredibly frustrating for me as a computer scientist. I'm also a professor at University of Michigan. Go Blue. It's incredibly frustrating for me because I know the scientific breakthrough to bring conversational AI to human is already here. It's right here, right now, right? So I believe, hopefully by the end of this talk, you'll believe as much as I do, that right now is best timing to bring robust, sophisticated conversational AI to everyone on the planet. But let me talk about why now. Why now is best timing. I'm going to take you back a little bit further in history and give you actually a quite quick preview of a few trends in computer science. So this one you all know, right? We're in the big data era, data, right? This guy's name's Alan Turing. So we named the most prestigious award in computer science after him, the Turing Award. In 2014, we actually gave the Turing Award to Michael Stonebreaker, a proud Michigan alum, I have to plug it here, for his contribution for database, which eventually powered big data era. I'm going to jump through this trend because we all know about this trend. The second trend, you may or may not know, but you are definitely experiencing this. That's exponential growth in compute infrastructure, processor speed. In 2017, we gave the Turing Award to Hennessy and Patterson, ex-Stanford Berkeley professors, now Googlers, for their contribution on computer processor design breakthrough. It's not a smooth path. So some of you guys may know about Moore's law. So it basically says in every 18 months, we're going to be able to pack twice as many transistors onto a chip. Right? We write this wave, or we've been writing this wave till 2014. Moore's law is dying, right? If you don't know, it's dying. You actually see it's plateaued a little bit. We're down to Intel's having real difficulty in fabbing a 7 nanometer chip because think about it, virus is 50 nanometers, atoms, molecules roughly 1 nanometer, so we're actually hitting the physics limitations. Luckily for us, in 2010, we realized that this is a GPU, right? It was invented for just play video games and so on. In 2010, a bunch of scientists realized that GPUs are really, really good of doing one computation, one very simple computation, matrix multiplication. And this really trivial fact actually has a fundamental impact on everyone's life in this room, right? What turns out to be true is matrix multiplication is one component, key component, doing this AI algorithm called deep learning or deep neural networks, okay? So we got lucky, we got a lucky break. NVIDIA stock actually went 9 times within 2 years because of this lucky break, right? But is that the best we could do? After spending billions of dollars on actually NVIDIA equipping Google's warehouse scale computers, those are actually 20 football field-sized buildings housing tens of thousands of machines to actually do searches and AI on the planet. So after spending billions of dollars purchasing GPUs, Google eventually got fed up and said, you know what, I'm going to build my own hardware. So Google invested into innovation in hardware and built this thing called TPU. So this is tensor processing unit, right? You could do one computation really, really fast, and you guessed it, matrix multiplication, right? This is for deep learning network, and I'm going to talk a little bit about that in the next slide. And as a matter of fact, it's so fast, it's 180 teraflops of glory, right? Is Google the only company on the planet to do this? No, everyone's doing that, right? As a matter of fact, you have an NPU, you have a specialized processor just in your hand. This is Apple's chip. And you can see here, there's a neural processing unit right on the Apple's chip, right? So you actually have that specialized hardware already helping you to do deep learning. So I'm going to go to my third trend, which is AI algorithm breakthrough. In 2018, the Turing Award last year was given to Geoffrey Hinton and his colleague for their breakthroughs in deep learning algorithm. So a lot of research in Turing Award was actually done on speech recognition and vision, but I'm going to explain this in the context of conversational AI and natural language understanding. So essentially what this means is AI is now transforming from symbolic AI to deep learning. So the symbolic AI, the way they see natural language understanding, for example, is I see a sentence. The AI is going to actually try to build a path tree of the sentence. So it's going to actually understand the nouns and verbs, adjective of the words, or which identify from the words. And it's going to actually identify the relationship between the words and build a path tree. It's super bottom up. It's very brittle to do this. It's actually very limited to grammar rules, very difficult to do for different languages. And this is also now how humans really learn language, right? You don't remember my last 10 nouns or verbs or adjectives, but you understand me perfectly. My 3-year-old doesn't understand grammar rules, and he can understand me perfectly. Hopefully one sentence on deep learning. So the deep learning is basically saying we're going to do completely data-driven. So deep neural networks essentially as algorithm is basically saying the math model is tons and tons of neurons, layers and layers of neurons built together. So when you train this particular model, you give it tons of examples, data, sentences, and understanding of the sentences. What you're really training is you're tweaking the connection and the strength of the connection between neurons. So after billions of words, billions of thousands, tens of thousands of examples, this particular model will be understand you perfectly, just like my 3-year-old, how he actually learns how to speak without grammar and without rules. So this is the transformation that's happening in AI. So I'm going to explain why those 3 trends are so fundamental for this big breakthrough that's happening right now. What happens with deep learning algorithm? You think it's such a great breakthrough. It was invented in the 1970s and 1980s during the AI winters, right? It was underperforming any symbolic AI, any expert system, the support vector machines for decades, right? So AI went through this winter, new hope with expert system. We thought it's going to actually break through, but it was super brittle, and the AI winter again in 1990s, until explosive amount of data came along, until we actually finally figured out how to actually compute the data on super, super fast machines, until the mobile actually evolution for hardware. All 3 things came together. It's wonderful to see 3 different threads in computer science in the field eventually came together and beautiful things came out of it, and that's the breakthrough you see right now, that we'll be able to actually use deep neural networks to calculate super precise models, right? And that's the beauty of the collision of ideas. So that's the explosive growth that we're actually experiencing. So now back to the reality, right? And now hopefully you believe as much as I do that the breakthrough's right here. We can do better, and we should do better, and that's how we actually founded Clinc. With the encouragement of the Australian police force and Japanese fishing company, we want to be able to bring robust conversational AI to everyone on the planet. And it turns out that people don't only want to talk to their computers, they also want to talk to their phone, their restaurants, in the car, talking to a bank account, talking to doctors, talking to video game characters, everything. And with that, I'm going to play a video of Jason demoing. He could actually do it here on the live demo, but we're not going to do this for the video, right? Okay, all right.
Hey, so, I was in California last year. I like to go there. And I remember I dropped a bunch of cash on food. Can you tell me how much that was?
You spent about $733 from your 3 bank accounts on food and drink in California, which is 1.95% of your total spending from January 1st, 2018 to January 1st, 2019.
What about when I was in Ann Arbor, Michigan?
You spent about $2,676 from your 3 bank accounts on food and drink in Ann Arbor, Michigan, which is 7.11% of your total spending from January 1st, 2018 to January 1st, 2019.
All right, well, I want to take everyone in the audience out to a fancy dinner. Should I drop, $500 on dinner?
Based on your spending habits, spending an additional $500 on restaurants would put you 78.46% above your average monthly spending.
And now I'm going to go order some food using Clinc's technology. All right, well, man, I'm really hungry. Hook me up with a chicken sandwich, some waffle fries, and a large Coke.
Of course. Anything else today?
Actually, my wife also needs a chicken sandwich, so let me get her one, and could you add some extra pickles and ketchup on that?
Absolutely. Anything else?
Yeah, so I heard about this crazy strawberry milkshake. What's on it?
Our creamy milkshakes are hand-spun the old-fashioned way each time and feature delicious Chick-fil-A ice cream topped off with whipped cream and one crucial cherry.
I'll take one of those.
Positively. Anything else today?
Nah, that looks good.
Your order is 1 Chick-fil-A chicken sandwich, 1 waffle potato fries, 1 large Coca-Cola with 1 Chick-fil-A chicken sandwich with pickles and ketchup, 1 strawberry milkshake.
All right, let's do gaming real quick. Hey, so I want to buy some of your cool stuff that you might have in stock. What do you got for me?
Take a look. You will find everything to be of excellent quality.
That's good. Ooh, that's a lot of gear. I don't want to look through all of this. I just want to hear about it. So let's ask another question. Hey, I gotta kill this vampire. Can you show me all your holy weapons?
These are all of the weapons I have that are wholly enchanted.
Wow, well, I like that steel crossbow. Can I have that one?
Excellent. Our current trade will cost you 1850 gold.
Thank you very much. That's Clinc.
The timer's telling me I'm out of time, so I'm going to run through this super quickly. We're in a lot of actually companies helping different verticals bring conversational AI. This is our user growth. Typically, when you actually launch conversational AI, you see this hump, people at the hype curve, and then you drop down. It's pretty what like Alexa looks like. And this is our consistent active user growth when we actually launched to a 6 million mobile user in Turkey, in Turkish, native Turkish, and they built it on our platform. We didn't help that much. They won Stevie Awards for their best service, with a fantastic containment number, which is actually the accuracy of the AI. The industry standard is roughly at 20-30%-ish. We're launching in different continents. We did a big fundraise. It's one of the biggest in conversational AI. And we just won Frost & Sullivan's technology leader for AI this year. So with that, thank you very much, guys.